In this set of examples, I'm going to show you how to simplify different trig identities, or specifically how to simplify different trig expressions. I'm assuming that you know 4 different trig identities and can use different variations of these. So sine of x over cosine of x is equal to tangent x. Keep in mind that you could multiply both sides by cosine of x, and that would give you sine of x over cosine x equals tangent of x. If you multiply both sides by cosine of x, for example, you would find out that sine of x is also equal to tangent of x times cosine of x. You could divide both sides by tangent, and you could show that cosine of x is equal to sine of x over tangent of x. Different possibilities there. With these other ones, usually you're just changing these around to sums and differences. For example, I could do 1 minus sine squared of x, and that would be equal to cosine squared of x. If I subtracted sine squared from both sides, if I subtracted tangent squared from both sides, I would find out that secant squared of x minus tangent squared of x is equal to 1. Or if I subtracted cotangent squared x from both sides, I would find out that cosecant squared x minus cotangent squared x is also equal to 1. So I may refer to some rules that are not specifically exactly these 4 rules, but they should all be versions of those rules. So again, when you're doing these problems, you may want to write those 4 rules down and use those rules to switch things around. And if you see anything that looks like any of these statements, it's a possibility that you may want to replace it. All right, so let's look at these problems. The first example here, I want to simplify the tangent of theta times the cotangent of theta. And one of my personal rules is if I see something that's a reciprocal function and I have multiplication or division, a lot of times I'm going to switch it into the opposite form. And more often than not, you're going to see nice things happening when you do that. So I know that cotangent is the same thing as 1 over tangent. So that's tangent of theta times 1 over tangent, the reciprocal of tangent. And of course, if you multiply that out, that's a tangent of theta over 1. We just end up with tangent of theta over tangent of theta, which just simplifies down to equal 1. Okay? So anytime you multiply a trig function by its reciprocal, you end up getting 1, which shouldn't really be all that shocking. But those types of facts can be used in a lot of these problems. Now you have to be careful, because if I took the tangent of theta and divided by the cotangent of theta, remember when you divide by a value, you actually multiply by the reciprocal. This is the same thing as tangent of theta divided by 1 over tangent of theta, which is the same thing as multiplying by the reciprocal. That would be tangent of theta times the reciprocal of this thing right here would be tangent of theta, and that would be tangent squared of theta. So be careful. Don't just decide, well, I see 2 reciprocal functions, the answer is going to be 1. It depends. If they're being multiplied, then you're going to end up with it canceling out to 1. If the 2 reciprocal functions are being divided, you're actually going to get a square of that trig function. So watch for that. Okay? Second example here. I have cosecant theta times cosine of theta times tangent. Cosecant is 1 over sine. And so I start thinking that maybe that might be useful in some sense somewhere in this problem. So I'm going to write that as 1 over sine. So that's going to be 1 over sine of theta times the cosine of theta, which of course is over 1, times the tangent of theta. And the thing I like about division and multiplication is you can move all these things around any way you want to, and you can break them up strategically. I see a lot of sines, cosines, and tangents showing up here, and so my thought is maybe I can use this identity and replace that. So the thing that I pick up on is I know that sine of x over cosine of x is tangent. Notice here I have a sine of x and a cosine of x in opposite parts of the fraction. It's the reciprocal of what I want, but that would just end up being the reciprocal of tangent. So I'm going to write this as cosine of theta over sine of theta times tangent of theta. And again, always be careful when you go through these problems. Make sure you're really following the identities, and make sure that every step you take is an equivalent of the original function. Okay, and so you can see here, if I break this up, I can turn it back into this statement over here. It's the same thing, just written in a different form. This is cotangent of theta, and And we just showed before that cotangent times tangent is just equal to 1. So cotangent times tangent equal to 1, and I'm done in that case. So interestingly, we get 1 twice. Don't assume that they're all going to work out to be 1, but that does come into play quite a lot in these problems. Okay, this example here, again, it's a fraction. There's no addition or subtraction. If there was addition or subtraction, I might have to think about breaking it up into 2 separate fractions using common denominators, maybe having to do something with factoring. Don't have to worry about that here. I can break this up any way I want to. Let's see, the thing that jumps out at me here is the cosecant is the same thing as 1 over sine. So I'm going to write this as cosine of theta over tangent of theta times 1 over sine of theta. And again, I can kind of shuffle some things around here. That's going to be the same thing as cosine of theta on top over sine of theta times 1 over tangent of theta. Okay, notice still have just a cosine on top, still have a tangent and a sine. I'm just kind of reordering how things are being arranged. And notice that this is cotangent of theta. That's the reciprocal of cotangent of theta. I don't really want to keep something in the reciprocal form, so I'm going to replace that with the cotangent of theta as well. And if we go through the process here, we found out that cotangent of theta times cotangent of theta can really just be written as cotangent squared of theta. So that's my solution for that problem. Next example, I see a sine squared and a cosine squared, and it seems a little strange because it's being subtracted, but I'm thinking maybe it'll link into the sine squared plus cosine squared equals 1 formula. How do I handle that 2? Well, I noticed that there's a -2 for both of these. If you've got a sum or a difference, don't have to worry about it with products or division, but if you have a sum or a difference, you may want to try factoring out a greatest common factor. So I'll factor out a -2 here, and again, make sure you divide it out of both terms of your sequence. That's going to be -2 times sine squared of theta. If I divide out a -2 here, that's going to become a positive cosine squared of theta. And this is fantastic, and this is the kind of thing that you want to see. Notice, this guy is equal to 1. -2 times 1 is just equal to -2. So this one canceled down to a number, but because of that greatest common factor that had been multiplied in at the start, didn't simplify down to 1. So be careful just assuming everything simplifies to 1. My last example here, tangent squared minus sine squared. I actually checked over here to see if that follows one of these ideas. It doesn't. Over tangent squared sine squared. Now, I noticed something when I looked at this problem. I noticed that it looks like a tangent squared cancels here, maybe some sine squareds cancel. You have to be really careful. This is not a product. If the numerator was a product, then I could cancel things and actually it would end up being 1. But the numerator is a difference, okay? The only thing that I can do is break this up into 2 separate fractions. When you're adding and subtracting with fractions, you have to have a common denominator, unlike multiplying and dividing. So I'm going to break up the numerator. And again, everything I do has to be an equivalent. So I'm going to have a tangent squared of theta over a tangent squared of theta, sine squared of theta, minus a sine squared of theta over a tangent squared of theta, sine squared of theta. Okay? What's going to happen here? Now a bunch of canceling happens, but be careful when you're, and notice, common denominators here, we add or subtract numerators, you would get the same thing as this. So everything is completely legal up to this point. Now, because I have no addition or subtraction, I can start multiplying and dividing common factors out of this fraction. So you can talk about canceling tangent squared, but again, be careful. You really aren't canceling it, you're really dividing out a tangent squared from numerator and denominator. Tangent squared divided by tangent squared is 1, okay? Sine squared divided by sine squared is 1, okay? And again, it's kind of sloppy, so you probably want to rewrite it. That's 1 over sine squared of theta. Remember, when you have a product or a quotient, you can write that product or quotient, and exponent rules will apply to it. I'm going to rewrite it, instead of writing as 1 over sine squared of theta, I'm going to write it as 1 over sine of theta, quantity squared, okay? If I square both of these terms here, because exponent rules apply to both parts of a fraction, I get 1 over sine squared which is what I was supposed to have here. And then minus, I'm going to do the same thing here. I have 1 left and a tangent squared left. I'm going to write it as 1 over tangent of theta squared. Okay? And what you notice now is 1 over sine is cosecant. That's cosecant squared of theta. This is 1 over tangent. That's cotangent. And that's cotangent squared of theta. And I saw a cosecant squared and a cotangent squared, and I said, wait a second, I've seen this before. That's coming from this right here. If you take cosecant squared minus cotangent squared, you get 1. And so this whole thing here actually just simplifies down to 1, which is interesting because when you look at the original, that's definitely not something that you think you're going to see. So that's the basic idea. Look for greatest common factors you can divide out. When you're multiplying or dividing, write reciprocal functions in different forms, break them up to try to find, for example, a sine of x over cosine x. Lots of different strategies that you can use, but pretty simple ideas. You just have to know what you have available in your toolbox. And sometimes it takes some trial and error, but eventually you're going to get something to simplify down.